Okay, so SNPs we've dealt with, gene mutations, you know how to do this. So I'm not going to stop on these because we need to cover, everybody's done this. All that module that we did is all on the internet anyway to watch free of charge. I just want to update you with anything. You see these, this was the original one I must have done 10 years or so ago now. And the original one was the methylene tetrahydrofolate, which is probably off the bottom of the chart. That's it. It's off the bottom of the chart, isn't it? Yes. So what was the original one of how I got the idea of when the uracil went into the thymidine position. So you had U into T. And this encoded for methylene, which is CH2 tetrahydrofolate. So remember the CH or methanol, otherwise known as folinic acid, and up here the methyl tetrahydrofolate, this one, are all made from folic acid with zinc. So you're able to make that. So as I go through any of these, you may want to write them down, how you make them if we haven't got them available. Right? So methylcobalamin is available, and it was one of the first ones we did in liquid form. Thiamine pyrophosphate. Okay, this is the active form of thiamine. We convert thiamine into thiamine pyrophosphate. It needs ATP. So you simply need thiamine plus magnesium. Okay, so you put on the patient thiamine and magnesium. We make a product now of that. We call it the horse mix because it's used a lot with horses. Get them over their fences a lot better, and it gives you the zap. And that's the mix that you use, you know, to get the immune system going as well. So thiamine with magnesium. So to make thiamine pyrophosphate, you simply need thiamine and magnesium. SAM, you simply need rosemary powder, or capsules as it will be. FAD, flavin adenine dinucleotide, is vitamin B2. That's your riboflavin 5-phosphate, which is already available. Adenosylcobalamin is already available. These are all in liquid form. Thiamine triphosphate is just double the amount of magnesium to the thiamine, so that's already available as the thiamine with the magnesium. Methyl tetrahydrofolate, that's folic acid plus zinc, as I said. Vitamin C, you've got the choice there. It could be plain C, could be C with alpha lipoic acid, or probably what you'll find is the C complex suits people much better and tests better. So C and alpha lipoic, or vitamin C complex. NADH we now do as a liquid. Nicotinamide adenine dinucleotide reduced. It's a good long mouthful, isn't it? Carboxybiotin or biotin is coming out next week. We've just got to simply work out what is the optimal dose. That'll come out as a capsule. It doesn't go into fluid very well. It tends to go off. You know, you gain very quickly, you find things floating in it. And, you know, sometimes people do find things floating in it, and I apologize for this, in their active coenzymes. There's not much we can do about it. We've tried all sorts of things. We're having a run of pyridoxal 5-phosphate at the moment, which is going off. So we are talking about going into a capsule for a while, but we'll retry it. It seems to be the seasons. It's when it gets damp, you get spores in the air. Spores get in during the manufacturing, and then they love it. They just grow. And it takes one spore to get in there. However, you know, with all the air extraction and everything that we got, and it may be, you know, sometimes in the powder. We just don't know. But luckily, we've gone for years or year and a half without it. And we used to have it with the old company all the time. But it seems to come and it goes, and you know, we don't give up. But I will not put a preserver in there, because if I put a preserver in there, somebody's going to weaken to the preserver, and you don't know what you're testing then, do you? If you've got two things in there, you don't know which one a person is strengthening to. Could be the preserver. You see, which she is. Okay. P5P, that's the one we're talking about. P5P is, of course, been available all the time. Tetrahydrobiopterin, that's in the pipeline. That's a difficult one, but I have got that one working with the coenzymes, that one. So that's around. NADP and NADH, those are in there. FMN, flavin mononucleotide, that's riboflavin. Lipomide is your alpha lipoic acid, that's now available on its own. CoQ10, beautifully done with the old Wonder Oil, the peanut and sesame, shows a lot. Tetrahydrofolate, methanol tetrahydrofolate, that's folic acid and zinc. And what's on the bottom there of the list? Have you got, is there another one on the bottom? Can you read it? It's tiny, is it? I'm sorry, it's, why is it that's gone off? What? Oh, CH2. Well, that's methylene tetrahydrofolate. That's again is folic acid plus zinc. Oh, you've got a CoA. Where? You've got a CoA. Oh, right. Okay. CoA is the active form of vitamin B5, so we use pantothenic acid there, and magnesium. I'm going to try and make that one up into a complex. So what is very important is that all these coenzymes are complexes. Okay? Pyridoxal 5-phosphate is not a complex. It's an active part of it. It's the refined part of B6 of what works. The B complex, as you see B6 complex, in nature of where you get it from, is different. It's full of enzymes. The plant is full of enzymes which make you make your own B6 activated. Okay? And that's far more important, really. So we're looking now at making a B6 complex with red bell peppers and so on in the extracts in there to make you make your own. So we give you the B6, but it'd be far more important to use natural substances. And when we come tomorrow to looking at the heart, you'll find that most of the times the heart will respond to natural substances. It doesn't like synthetic substances. And the more the chemist refines out, and this is what they did with vitamin C. Most people don't know that vitamin C is the protective part. The ascorbic acid is the protective part of vitamin C. It's not the actual active enzyme. The enzyme is called tyrosinase and was discovered to be a vital part of vitamin C in 1932. But they've refined ascorbic acid because they can make ascorbic acid cheap from sugar, from glucose. Yeah. Oh, that's the. I'll use just scratching it. Yeah. Okay. Yeah.
What if you've got someone with a SNP for say FAD?
Yeah.
B2, but they're a red and B1?
Well, you have to give it. You have to give what test for the person. Those are general constitution. It doesn't mean that a red would never need B2. You know, you could have it. So I'm not going to say a red, because B2 is very necessary, as we'll see tomorrow, to open up the coronary vessels. If you're potentially a coronary heart case, you want to open those vessels up as quick as possible. Now, nothing will open your vessels up quicker than B2 and B3. Have you ever had a niacin flush? Would you like one? Could we arrange one over there? It's great fun. You feel heaps better after half an hour when you've had it and it's stopped. Okay. So it cleans out all your tubes, and that's what you really need in your coronary system sometimes, is to clean them out. So B2, B3 are vasodilators, very important. If you're a red, it may be important. But the B1 is something which is more for the neurological side of the heart, and the B2, B3 for the vascular. Okay? So the poor old red is more of a vascular. That's why they show to the B2, isn't it? It's the greens and the blues who show to the B1. The red is the only person who shows to the B2. Okay, because they've got more prone to this. Okay. So assessing optimal nutrition, we've done all this. So this again is available as a laminate, or you can just download it, which is useful because it tells you and reminds you of how you make all these different coenzymes. There we are. See, there's alpha-lipoic acid, octanoic acid, which is carbonate, or otherwise known as caprylic, cysteine, and thiamine pyrophosphate to make alpha-lipoic. That then links with lysine to make lipoamide, which is the active substance. So epigenetics are mechanisms that lie outside of the DNA sequence of the genes. One of the initial discoveries was the effect of DNA methylation upon gene expression. So this is keeping the caps on the gene. This methylation, DNA methylation, usually is associated with the methylcytosine part, which leads to silencing of the transcription in vertebrates. So what happens is we have our DNA is coiled around with proteins called histones, and what will happen is the methylation will keep the histone tight, so it locks it up, and a lack of methylation will slacken it, which allows that gene to express itself. Remember I was talking about the proteins, so if you have a lack of methylation, it could expose the oncogene, which is what you don't want. So let's just have a look at methylation. This is a, yeah, that'll be an easier one to understand. So this is one associated with methionine. So methionine is an amino acid, and what it goes on to make is S-adenosyl methionine, which is known as the universal methyl donor. So if a person needs methylation, this would be the way that you do it, which is then metabolized to S-adenosyl homocysteine, to homocysteine, to cystathione, and to cysteine. Okay? So this is the important part here. So if we want to make more S-adenosyl methionine, we don't want to metabolize all our methionine down this route to cysteine, because we'd only make a certain amount. So what we want to do is to recycle the homocysteine, which is why we have this pathway, to recycle it this way, which requires methylcobalamin, or the B12, to take you back to methionine to make more SAM again. So in order to make more SAM, you need more B12. And the active form of B12 here is methylcobalamin. And to make methylcobalamin, you need methyl tetrahydrofolate, or the active form of folic acid. So folic acid donates its methyl group to B12, which is methylated, which then hands its methyl group back to homocysteine to make more methionine. So this is really important, to go round and round and round and round. Now we can also, in the liver, move homocysteine this way through the liver by oxidation of choline. Now we want to talk briefly about choline. So choline can be oxidized to betaine, or trimethylglycine, and then again to dimethylglycine, to sarcosine. And each time it does that in these three, it gives off a methyl group. So this is a very effective way, which is why when we put in homocysteine metabolizing formulas, we put choline in it. Okay, because choline is very effective, choline bitartrate, as a methyl donor. So in this case, what we find is that homocysteine is very necessary for blue people. So blue people need homocysteine, do you see? Because the more homocysteine they make, the more, as long as they got the B12, the more they can cycle it. And the more SAM they make, the more methylation they can do. Okay? The red person wants to get rid of this stuff. Okay, the red person has a high level of homocysteine, therefore they want to get rid of it. So if you've got homocysteine as a problem, you want to metabolize it. And the normal way of metabolizing it is this pathway, which requires B6 and vitamin C. So these two are the most important ingredients for the red person. Okay? So if you go back to the red person, they need it this way. The blue person loves homocysteine because it makes them more methionine again. So I'm not going to go through all the toxins. In fact, I cut all this out because it's all in the manuals of the past seminars. Okay, so that in your manual you haven't got that in your notes, but if you want it, just download the cancer module if you didn't come on it. So let's have a look at hypoxia as a big important part of cancer. So with hypoxia, we know that we've got a lack of the use of oxygen in the cancer cell. So the cancer cell doesn't use oxygen. It works in glycolysis, which is anaerobic. And as a result, it tends to make lactic acid. Now here we see the energy pathway, which is glucose, and going down to making pyruvate, and this is all called glycolysis. Doesn't need oxygen. And it's quite interesting because there's inhibition of different enzymes by different poisons. And a lot of these poisons are metals or heavy metals that can inhibit our function. So here we see pyruvate is outside of the mitochondrial membranes, and acetyl-CoA is inside the mitochondria, and that's what is the substrate for the Krebs cycle. Then in the mitochondrial membranes is where we make the last part of making energy, called the electron transport, and that's where we need our coenzyme Q10. So here we need our specialized nutrients to get pyruvate across the mitochondrial membrane. Now this mitochondrial membrane are made of phospholipids or oils. Okay? So we've got to get oxygen into the mitochondrial membrane for us to make the last part of energy. So we've got to get the oxygen across the phospholipid membrane of the mitochondria. Okay? So we've got molecule of oxygen which has got out of the blood, out of the red cell, across all the membranes, and now it's got, let's say, outside the cell. How does it get across? The only way oxygen gets across membranes is by diffusion. By the higher concentration of the oxygen forces it in. Okay? It's literally the pressure of the oxygen. The higher the pressure of the oxygen, the greater amount will be delivered into the cell. And from there, it's then got to cross over the mitochondrial membrane. Now, say the mitochondrial membrane is full of oxidized trans or the wrong types of oils. Okay? It'll go harder. It'll be more like a ping pong ball than a bubble in the bath. And that makes it very difficult, impermeable, for oxygen and other nutrients to get across. So this is what happens really with the cancer case, is this membrane is hardened. So they can't get the oxygen in. So the cell, the cancer cell itself, can't work aerobically. It hasn't got the fuel to do it. Okay? It needs the oxygen. This is where the hypoxia comes up. So this part, the Krebs cycle or citric acid cycle, and then the final bit is the electron transport or oxidative phosphorylation. So this is the bit we want to look at a little bit closer, because with all cancer cases, we have a high pyruvate, low acetyl-CoA. So let's have a look at that in a bigger picture. This is the mitochondrial membranes, the outer one and the inner one. This is the pyruvate, and you see if you can't burn pyruvate, what it does, it produces lactic acid. Okay? Now, lactic acid we found is in three forms. You've got the D, the L, and the DL form. And this corresponds exactly to the colours, in other words, to the body constitution. The D, which is the bad form, which is particularly difficult to metabolize, is in the blue. So again, blues have picked the short straw. They're unable to detoxify the D form of lactic acid. There is no enzyme that breaks this down effectively. It's very slow, which leads towards the buildup of lactic acid and creates an acidosis in the body, which is another common feature with cancer cases, is there's a systemic acidosis tendency, and to add to that, there's the hypoxia in the cell. So to get our pyruvate across here, we need vitamin B1 or thiamine pyrophosphate, and here we need our alpha lipoic acid as a carrier, and we need a bit of B5 coming here. And to recycle this, we need B2 and B3. So we've got B1, B2, B3, B5, just in this little bit. Very important. So you have a diet high in refined carbohydrate. You have yes, cornflakes is okay, it's not a trade name. Cornflakes for breakfast, okay? And you have white bread sandwiches at lunchtime, maybe a meat pie or something, or maybe white flour, okay? And then you have meat and 2 veg or whatever in the evening, and maybe, if you're really lucky, a nice jam pudding or something, okay? Maybe white flour. So all those calories, okay? But no vitamin Bs, okay? How on earth are you going to burn it up? You can't burn it up. So you've got to store it, or you're certainly not going to burn it up in the Krebs cycle because you've got no Bs in there, okay? So you're depleting your body progressively of the Bs, and all of a sudden you start getting problems. And when we go down in our B2, B3, we start getting vasoconstriction, okay? So vasoconstriction, as we'll see tomorrow, can lead towards coronary problems. You know, we don't want to constrict. When we have B1 deficiency, we're going to have a build-up of pyruvate, and we're going to be tired because we're not burning energy. This pathway of making energy, it probably makes you money as well. Making energy here is really very efficient. Only 4 atoms of ATP are made, as opposed to 38 with the Krebs cycle here. So very, very important here. So this is a very interesting part. So often with people with malignancies, they show the need for B1, sometimes B2, B3. But we can see B1 in the heart, because B1 will be something which operates the nervous system, and B2, B3 operates the vascular system. So tomorrow it'll be really interesting, because not only do you see the heart, but you see the nutritional need of the whole body, which includes malignancy. Because the malignant cell is demonstrating has occurred because of certain deficiencies and toxins, which you'll pick up in the blood system and through the heart. So things which help get our oxygen going: iron, B12s, as I said. Now folic in the different forms can also produce an anemia, So you can have folic acid deficiency, which can mimic B12. Okay? Now they always say you should take folic acid with B12, which when you muscle test doesn't work. Okay, put B12 and folic acid together, it rarely ever tests, because B12 should be taken at breakfast time and folic acid at night time when there's no hydrochloric acid in the stomach, which is why if you do a combined product, you'll probably never find it shows. Okay, but you don't forget folic acid with the zinc activates it, and that folic acid, active form of folic acid, can mature the cells and increase the concentration of oxygen carrying capacity. Essential fatty acids, those are important to get the oxygen out of the red cell, through the membrane of the blood vessel, into the cell that it has to go, and into the furnace. Okay, so it's quite a journey, that oxygen. Only way it goes out there is literally the amount of oxygen. The pressure is greater where it's coming from to where it's needed. Okay, that's called diffusion. There's nobody there to carry it. Vitamin A has been shown again to mature red blood cells. Now, vitamin A, I came across recently, is also a substance which has been used, and I was quite surprised about this, for aneurysms. I was quite surprised when I saw that, because we'll talk about aneurysms a little bit tomorrow, but I've never heard of vitamin A being used to treat people with aneurysms. Very severe problem, an aneurysm. So A and vitamin B6. B6 because it helps to make the heme part of the hemoglobin. Vitamin C complex because the complex part is what makes the blood vessels more permeable. It gives the elasticity to those blood vessels to allow oxygen to get across. Okay? If you've got stiff blood vessels, you've got all the oxygen being delivered to you, but it can't get across, can't get out. Okay? Iodine and selenium, because they help to spin the Krebs cycle to get it up. So the spinning of the Krebs cycle depends upon thyroid activities. So there's a number, and you can extend that out into other things which may have an effect on oxygen. But those are the prime things that I test when a person shows to hypoxia. So remember hypoxia you show with eyes up, eyes down, eyes up, eyes down. 9 times it's the heart meridian that shows, and they all strengthen to O2. So from a functional point of view, our challenge for hypoxia would a weak muscle strengthens to oxygen, as simple as that really. So the link between oxygen and cancer has been around for 80 or more years. Dr. Otto Warburg discovered the real cause in 1923, and in 1931 he received the Nobel Prize for doing this, and he said that all cancer cells are hypoxic. 1931. That was before they discovered about genes, and all the money went into gene research and things. And he said no, it was to do with a lack of oxygen within the tissue. So fatty acids, yeah. So D-lactic acid. So we get a build-up with hypoxia of, in the blue person, of D-lactic acid. And that's one of the best markers I find for cancer. Okay, there is no one marker which can say, yes, this person's got. But I do find universally all cancer cases weaken to the D form of lactic acid as they ferment energy. D-lactic acid is toxic and tends to prevent the transport of oxygen into neighbouring normal cells. Over time, as these cells replicate, the cancer may spread, if not destroyed, by the immune system. The ensuing acidemia tends to persist since D-lactic is not metabolized by L-lactic dehydrogenase, the enzyme that catalyzes the conversion of physiological occurring L-lactic acid into pyruvate. Thus, D-lactic acid is slowly metabolized in humans, which leads to acidosis. Circadian rhythm responses, very important to people who have circadian rhythm problems, you know, people who fly a lot, cross time zones at fast speeds, maybe have their body clock in New York and be back in London, but their body takes a little time before the clock comes back to catch up. Sometimes it takes weeks for people, but we all know about how to tap, don't we? I think everybody knows the tapping techniques. Okay, so we know that most cancer cases, when you actually question them, have sleep problems. So they don't sleep very well. They have disjointed sleep, which would indicate their pineal is not functioning, and they strengthen to melatonin. So if they strengthen to melatonin, then you need to help try and get this. We find taking melatonin when it's not necessary is rather difficult. It can give very disturbed sleep and a lot of dreams. If you need it, you'll sleep like a top. But if you don't need it, and some people use it routinely, it gives weird dreams. So recent research carried out in Cancer Watch suggests that circadian rhythms might even control the effectiveness of chemotherapy. Well, we've known that for 10 years of when to best give nutrients, when to best give medication. We know that we work with the body clock, the 24-hour system, the circadian rhythms, as to which one is the best time. Research shows that the immune system needs 9.5 hours of sleep in total darkness to recharge completely. That's a long time, isn't it? 9.5 hours. So doesn't mean everybody needs that, but if your immune system is knackered, which is basically why, you know, when you get an infection, you go to bed and you stay there and you just rest. It's the best thing for you. Melatonin functions to destroy cancer in multiple ways. First, because it is toxic to cells and it induces apoptosis. So a lot of sleep, good away from electromagnetic fields, is very important to stimulate melatonin. The finest way to stimulate melatonin, apart from taking the nutrients in that pathway, is meditation. Meditation will do it and is shown to raise melatonin very well. It stimulates the immune system to increase cancer celling, particularly the natural killer cells. Additionally, melatonin inhibits angiogenesis, which is the growing of new blood vessels within the tumour. Melatonin has properties which enable it to block the effects of the estrogen upon cancer cells, so it can block the cancer cell receptor site. Finally, it's an antioxidant, reduces inflammation, the conditions that enable cancer to survive. Okay, so we won't go into those. Hormonal connection we talked about. Remember, this is the bad guys are the 4-hydroxyestrone, 4-hydroxyestradiol, and 16-hydroxyestrone. Those are the bad girls. So if we have a look on the steroid chart, again, this is the steroid hormone chart, which you're familiar with. We produce estrogens from cholesterol to progesterone to androstenedione or androstenediol, testosterone, and then to estradiol and estrone. And then we have the 2, 4, 16 of both these being hydroxylated. So the 4 is the bad girl here, 16 is bad in boys and girls. This is the one that does the prostate with the men, and this is the one that's mainly is the breast cancer with the women. The 4-hydroxyestradiol is bad, but this one, the 16, is good. So they found out about 30 years ago that the ratios with breast cancer cases of estradiol to estriol to estrone is very important. And when the ratio was higher of estriol, or E3, to the combination of E2 and 1, which is estrone and estradiol. So this one needs to be higher than this one and this one together. So if you want to test really, very simply, you put estrone and estradiol on the person, and if they weaken to that, then that means they've got a higher level than this. And what in those early days they found is these people had a less life expectancy than the people who had the reverse around. So those who had higher estriol had a better life expectancy. And the nutrient that they found worked really well in that was iodine. So that was when we first started using iodine for treating prostate cancers and things. So iodine is a very important nutrient, plays a big role not only with the thyroid but in balancing the estrogens, and is an antiseptic as well in the immune system, particularly for red people. Blood, but you can do it with your muscle testing. You simply put on the 2 vials, and if they weaken, then try them with iodine. Okay, we would refine that now because we know a lot more. We know that it's the 4 and the 16 which are the bad girls, so you can actually test with those direct. Okay, most people are not deficient in estrogens. They usually are not excessive in it. They're excessive in the hydroxylated derivatives or the methylated derivatives. But when we're dealing with cancer, it's the methylated, it's the lack of methylation and the high hydroxylation which is the danger. So I'm going to, you can read those. So we all know about the good things about watercress and broccoli for these people, cruciferous vegetables, because they contain thiocyanates which are good for killing cancer cells. Fungi, a lot of people say when you're going to do a fungal formula, and again, I don't know whether the spices will work with funguses. I haven't really tried that much. What? They do. Yeah, I think they should clear the gut out of everything really in there. It would be a good idea. Nature's own way, strange enough, for killing funguses is urea. So if you want to get rid of athlete's foot, you pee on your foot, don't you? You pee on your toes. Okay? Nothing will get rid of it faster than that. Okay? So take your shoes off first and your socks. Don't take my word for it and go to the gentleman's there and do what you need to do to get rid of the fungus. But the nicest way to do that is to use a cream. Now we've done a lovely hand cream. It's called a hand cream, and it contains urea. Now it's better to say it contains carbamide. Carbamide is the chemical name for it. And carbamide has been used for many years as a moisturizer. And carbamide, or urea, is the natural substance which regulates the osmotic pressures in the body, the fluid retention. And in order to regulate the fluid retention in the body, we need sodium chloride and urea. And a lot of people, surprisingly, are deficient in urea. If you look at the urea cycle, if you remember that cycle on the chart, you'll see that we make urea from ammonia and from carbon dioxide. And that means if you're deficient in urea, you've probably got a build-up of ammonia. Okay? And to synthesize that, metabolize it, you need biotin. Okay, biotin is the nutrient that opens that up. If you have high ammonia, you can be quite ill. Ammonia is very neurotoxic to the brain and also nephrotoxic to the kidneys. Okay, it's a very nasty substance. So you need to open that up and create urea. Now, one of the things that you find with high fluid retention there is people swell in their legs. So you need to actually get the urea up by using the biotin or whatever shows with them to get the fluid out of the legs. Okay? So it can be useful. It didn't show you did it with the glaucoma, but it shows with a lot of people with glaucoma, with the build-up of pressure in there, is urea. So we do it as a nice 100 ml bottle. Okay? I think we'll label it carbamide, not urea. It doesn't look so good. Okay? But you need 1 or 2 squirts of that, and it really helps people to get rid of excess fluid. Okay? I think it's a toxic metal chelator as well. We're trying it out in capsule form for people with gut funguses. So we know that the grains contain often mycotoxins if they're left and they're contaminated, particularly when they're damp. So antifungals, citrated silver with B1, that's really good for all immune systems. Urea, castor oil extracts, really pungent, aren't they? That's the trouble with those. Coconut oil extracts, apple cider vinegar is a good one. Grapefruit seed extracts, the blue spice mix, and always check for essential fatty acids and zinc with people with fungal problems, because funguses only attack tissue which is not optimal. They don't attack healthy tissue at all. Right, so again towards the end, cell apoptosis. The key ingredients here is vitamin D. There's a lot of talk about vitamin D, isn't there? And vitamin D is something which is really, really important for us outside of the summer. Now it's basically because Jill made the suntan lotion, the sun lotion this year, in May, that we got the sunny weather. Okay? So we could use it. If we hadn't got the sunny weather, we would have never known all the good properties of it. Okay? So we promise you, again, next year, we'll make a large amount in May, maybe in April next year, because I forecast that next year will be hotter than this year. That's my forecast. How do I know? Okay, so get ready, get the suntan lotion in early. Okay. So vitamin D. Now vitamin D, we know, is responsible for elevating blood calcium. So if you don't get it from the food that you eat, what it does is it extracts the calcium from the food in the gut. It increases the carrying protein from the intestine to bring it into the blood. And if you haven't got anything in your gut at the time and you get a high dose of vitamin D, there's only one place you can get your calcium from where you store 90% of it, 99% is in your bones and teeth. Okay? So you will demineralize your bones. So people say, oh, I take vitamin D all the time. Don't do this. Okay? Do not take vitamin D unless you indicate that you need vitamin D. Now, supposedly, the sunshine will convert your cholesterol in your skin to vitamin D according to the amount that you need. This is the latest research. And the amount that you need is about 20 minutes of a 40% exposure in the summer. Okay, so remember, today was the last day, and we missed it, okay, of your ability to have the ultraviolet at the right nanometers wavelength to be able to go down to the 5th and 6th layer of skin to convert cholesterol into vitamin D. Okay, now if you take vitamin D over the winter, that's fine probably. Most people do need vitamin D in our level in November, December. You store about 3 months. But that's assuming you've been out in the sunshine. Most of us probably haven't been out in the sunshine really since the end of August, have we? That's, you know, when we tend to think. After that, the weather wasn't so good again. So we probably haven't topped up. So you September, October, November. So by the end of November, you probably will be rock bottom in your vitamin D. Okay? And not many foods contain vitamin D. But Frederick, you found out there's only one plant, one oil, isn't there, that contains vitamin D. And guess what that one is? Hemp, yes. But that's not the reason we use hemp as a carrier. We use the hemp because it's rich in phosphatidylinositol, which carries the vitamin D across the gut. Okay? So if you take vitamin D and you don't get it into your system, you might as well just throw it away. And the reason that most people don't get vitamin D levels built up is because it's a fat-soluble vitamin, not a water-soluble. So if you swallow a capsule of vitamin D with a glass of water, you might as well just chuck it over your shoulder. Okay? You've got to put it into an oil to get the body to absorb the oil. And this is the whole thing about why these cholesterol-blocking drugs, which stop you absorbing oils and fats in the diet, in the gut, are bad because they stop you absorbing vitamin A and D and E and so on as well. Okay. So it's pretty obvious that D should always be in oil, but the question was which oil? You know, is it okay if you put it into whatever oil, soya oil, whatever? The answer is no, it doesn't work any better. But in hemp it does, because it's rich, and it's well known, it's rich in phosphatidylinositol, and that carries it across. So our time for testing vitamin D will probably come back in November time, and to then build it up over the winter. Zinc is important for the enzymes with cell apoptosis. CoQ10, this is the other one. CoQ10 works really, really well in oil, again, but that oil is the wonder oil of the peanut and the sesame mix. Okay? That dissolves very well. CoQ10 needs to be taken last thing at night, not with the evening meal. CoQ10, probably like probiotics and folic, doesn't like acid. It neutralizes it in an acid time. So if you've got stomach acid in your stomach, it probably won't absorb very well. So take it on a spoon. Frederick, we were sort of averaging, you've had some people as low as 10, and I've had people up to 30 drops. So 30 drops is only half a teaspoon. Now, when you do an oil in a dropper bottle, what you find is you get many more drops with an oil than you do with water. With water, in a standard pipette, you get about 12 drops, maybe 13. But with an oil, you get 20 to 24 drops. Okay? So don't get into the habit, oh, well, that's 2 squirts, because that would be far too much. All right? So you do find with the oil, with the right oil, people need much less of the CoQ10 because it's in a natural medium which carries it in. If you take CoQ10, undo the capsule and put it into a glass of water, it'll just sit there. It'll float, but it will not dissolve. Okay? So therefore, if you swallow a capsule of CoQ10, it won't get in because there's nothing to carry it across. It's a powder. It still remains a powder. Okay? It's soluble in oil, but it has to be the right oil. Okay? And it doesn't like food. So if you swallow your CoQ10 with your meals, the chances are your absorption will be very, very small. Don't ask me, ask your heart tomorrow, because if you've got a person who shows positive to CoQ10 with the heart, they'll soon tell you, don't give me the capsule, give me the oil every time. Okay. And tocotrienols and black seed oil we'll talk about, I think, tomorrow. So vitamin D, let's go through that. I just want to finish this bit off. That's the importance of the vitamin D with the synthesis of pre-vitamin D2 in the skin involves ultraviolet B radiation, which effectively penetrates only the epidermal layers of skin. 7-dehydrocholesterol absorbs ultraviolet mostly affected wavelengths of 290 to 320. That's the midday sun. Okay, so and thus the production of vitamin D will only occur at those wavelengths. So remember how you test whether you've got enough vitamin D from the sunshine coming in? The length of your shadow. So tomorrow at midday your shadow will be longer than yourself, and obviously all the rest of the time. Now we were fortunate enough to do this seminar in Hawaii in August. Somebody had to do it, you know. And I said at 1 o'clock, no, at 12 o'clock, because there's no change in the time zone there. I said to Jill, I said, I'm just going to go and stand in the sun a moment. So I stood in the sun, and I thought, ooh, I've turned into a vampire, there's no shadow. And I thought, oh, and of course the sun was exactly above, so there was no shadow at all. Okay? So when the shadow gets to 6 foot, in my case, if it's under that, it means the sun is higher than 45 degrees, and you will be producing that wavelength. It'll produce that wavelength of ultraviolet B. When it's lower than that, the wavelength is longer than that, and that will not penetrate. And you can take your top off tomorrow if it's a good day, like today that they promised, a sweltering hot day. You won't get a suntan, and you won't get any vitamin D. Okay? You've got to go down south, and they reckon that you've probably got to go down as far as North Africa. Okay, for us in the winter time, or up a mountain. So a mountain will give you the extra height, as if you're going further south. So go skiing in the Alps, something like that, or catch the train to Marrakesh, okay, for the winter. Or Canaries. Canaries are probably the quickest there. Okay, so that's that one. So there's all sorts of stuff that you can read about vitamin D. Vitamin D, I discovered, increases the expression of the tyrosine hydroxylase gene in the medulla, adrenal medulla, to synthesize L-dopa, dopamine, and noradrenaline. And this is why people feel better when they're in the sunshine, isn't it? So you make vitamin D from the sunshine, and this boosts your dopamine level. And dopamine is the good factor, it's the feel-good factor. And noradrenaline gives you the zap. Probably also works on tryptophan hydroxylase to synthesize serotonin and melatonin levels. But most important here, it works on cell apoptosis. So there's the picture there, liquid vitamin D3, organic in hemp seed, and 1 drop delivers 2.5 micrograms, which is 100 international units, which is 50% of the EU RDA. So zinc, we talked about zinc before. Different forms of there. CoQ10, we talked about that. And this is the new CoQ10. 5 mil of this will deliver you 30 milligrams of CoQ10 in oil form, best taken last thing at night. Optimal absorption is with equal parts of peanut and sesame seed oil. So keeping your gut clean is important in all malignancies, and that's the colon cleanse that we do, which is psyllium husk, psyllium seeds, organic rice bran because of the danger of arsenic, so always avoid rice bran if it's not organic. Nettle root, again that should be organic nettle root as it is in bentonite clay. That's the immune formulas. Let's see what else. Vitamin C we talked a little bit about. I want to talk about that tomorrow. That's the new vitamin C complex. So vitamin C we'll talk at length tomorrow. Ascorbic acid, and the natural source of the tyrosinase enzyme is reishi and shiitake mushrooms. That's the tradition. So it was the shiitake mushroom that they first isolated in the 1930s, the tyrosinase. And tyrosinase, as we'll see tomorrow, is an organic copper-dependent enzyme. It's also present in beetroot. Beetroot has some wonderful other properties to do with vasodilation because it contains arginine, and this is very good with our heart. So the vitamin C complex is something that goes up with a lot of people with heart problems. So with me, I found that my first, the distance of my first and second sound was much closer. No, yes, it was the same distance as my second sound to the next first one. Okay, that is often an impending coronary. So the heart resting period in the heart is not long enough. Okay, so I thought I better do something about it. Okay, so I took the C over 3 weeks, and now my length is much better. Okay, so you can see changes very, very quickly in the heart. And I'm going to show you Sally just before we all disappear off what she should be like to give you a better picture. Sorry, back on there. We put hesperidin in there because that's the bioflavonoid that is from grapefruits, and rutin, which is the traditional buckwheat one for the permeability, and alpha lipoic, so the whole thing recycles itself, so you don't have to keep taking it. Vitamin A. Just to finish off their diets, the only one worth talking about really is the ketogenic diet, which is the one to keep the sugar levels down. Many cancer patients are reportedly overcoming the disease by adopting ketogenic diet, which calls for eliminating carbohydrates and replacing them with healthy fats and proteins. This is so you can put your energy pathway straight into the Krebs cycle and starve the cancer cell. Remember, the cancer cell is anaerobic, so you don't give it any glucose because that's all it can eat. Okay. Animal studies have shown that mice fed carb-free diets survived highly aggressive metastatic cancers even better than those treated with chemotherapy. Your normal cells have the metabolic flexibility to adapt from using glucose to using ketone bodies. Cancer cells lack this metabolic flexibility, so when you eliminate carbs, which turn into sugar, you effectively starve the cancer. So is cancer, this is a provocative question, a nuclear genetic disease or a mitochondrial metabolic disease? And the general, more natural world is coming round to the latter, and the more orthodox world is still holding on to the genetics. So, big split there. So always choose the diet that you enjoy, as it's important that everything you do in life brings you joy and not misery. Fair enough, really, isn't it?